This is the CloudNout podcast, your launchpad for Amazon Web Services.
Welcome to the first live event of cloudonaut. So we are going to look into how you can record AWS API calls on EC2 machines to improve your IAM policies. My name is Michael Wittig. I'm an independent consultant at Wittix. I'm also working as a technical writer at cloudonaut. And besides that, I'm the programming founder of Marbot, a chatbot to help you monitor your AWS account. So you can send me feedback on Twitter. My Twitter handle is hellomichibai, or you can also send me an email, michael@cloudonaut.io. So I encountered a situation like this many times before. I am looking through an IAM policy and I have to now decide if this action is really needed or not, because I want to follow the least privilege principle. So only allow the things that are really needed. So for example, is autoscaling complete lifecycle action really needed? Is it really needed to list all the IAM users here for this instance? And is the instance really, should the instance really be allowed to put everything in the CloudWatch service? So that's a question and the problem is to answer this question properly. So what do we want to do? So we could record all the API calls of the machine and see if this matches with the list and what we see in the policy. And now you think, okay, there's CloudTrail for doing that. And that's true. So we have CloudTrail. CloudTrail is the audit log of API calls in AWS. And in theory, that sounds like a good idea. In practice, it turns out that lots of API calls are not recorded by CloudTrail. So we need something else here. And there's a different situation that kind of requires the same data. So you have an application, maybe you bought it from a vendor, and now this application comes with AWS integration. So it maybe could interact with S3 buckets, and maybe it interacts with SQS or DynamoDB. So you set up all of that and you configure the application, and then you look into the documentation to get the IAM policies that you need. And it turns out the documentation is not really complete. They miss the IAM policies. So what do you do now? And one thing that you could do is you can just record the API calls that the application make, and by looking at the data, you can construct the IAM policy that is needed. So what do we need to do that? And a feature that is very handy that helps us here is called client-side monitoring, CSM for short. Client-side monitoring is part of all the AWS SDKs and the AWS CLI. And it records all the calls that are made, and by all, I really mean all the calls. And it pushes the data to UDP port 31000 on the loopback interface. So it's available only on the machine. And what we have to do is we have to capture this data and then we can analyze it. So what we're going to talk through in the next 30 minutes is this. So first we will turn on client-side monitoring, and after that we will see how we can capture this data and send it to S3. And then we will look into how we can analyze the data, because that's actually where we get the value. And I'm also going to compare the results with CloudTrail, because you might already know, isn't there a service called CloudTrail that actually solves this problem? And if you have tried to use CloudTrail for this purpose, you will soon figure out that it misses a lot of API calls. So we will see this at the end of today's event, that actually quite a lot of calls are not visible in CloudTrail. And then after that, we have some time for questions. So let's dive into the AWS console, where I will show you how to enable client-side monitoring first. So I'm going to SSH into a machine, and I'm using Session Manager for that. So that's an easy way to get a remote shell to a machine. And the first thing that I'm going to do is I will enable client-side monitoring in the so-called shared configuration file of AWS SDKs. And this file usually lives within the .aws folder. So I will create that here. And then within that folder, the file is called config. So I will create this file here because it's not yet created. And the content that you add here is we want to enable client-side monitoring, and I'm going to increase this here a little bit to make it easier for you to read it. So per default, like all the profiles will use this setting, and I will enable client-side monitoring. Now for the root user, client-side monitoring is enabled. And that's pretty nice, but on this machine, there are other users as well, so I can just check out the list of all the users. And as you can see, there's quite a bunch of users, and I also want to add this setting for the EC2 user, so that's the default user on Amazon Linux. So it makes sense to add the setting there as well. So I will create again the AWS folder, and it could be that it's already created in your case, but for me it's not. So this is a fresh system. And I'm going to add the same settings here. So keep in mind that this change only takes effect for processes that are started after the change. So processes that were running before the change will not be affected. Now let me quickly change the ownership here of the new folder. Okay, great. So what I'm going to do now is I will see if the configuration is working. And the way client-side monitoring works is it sends requests to UDP port 31,000, and there we can see all the requests. So I will open a new session from where I will make some API calls, and then hopefully we can see them on the other side. So I'm now the EC2 user. Oh, I'm now the SSM user, sorry. So let me switch to let me switch to root, so that's easier. Okay, now I'm the root user. And I will issue an API call. So this is getting me the list of S3 buckets. I'm not allowed to do this, but that's not a problem. It will still pop up here. And we can already see this call. The API request is called list buckets. And we can also see that I get an access denied. So for all the users on the system, like the root user and the EC2 user, client-side monitoring is turned on. And that's pretty cool. So, but what about like system processes? So how can we turn on client-side monitoring for them? And I will look into the running processes on this machine here. And as you can see, there's quite some stuff going on. And I will pick the AWS logs application. So that's the agent that ships logs to CloudWatch logs. And I'm going to look into this and see if it is configured properly. And there's a nice command that we can run here to do that. And I need the process ID. So that's the process ID. And this shows us all the environment variables that are available in this process. And that's pretty cool. And as you can see, this one has the environment variable home configured. And by default, this means that the shared AWS configuration file will be fetched by the SDKs. So if you see the home variable and this points to one of the users where you configured client-side monitoring, then you are fine. But we have to look a little bit more careful here, because we also see the environment variable AWS config file. And this actually overrides the default location, which is in the home directory. In this case, we explicitly tell the SDK to look into this specific file for the configuration. So what I have to do is I have to modify this file, and you will see it looks exactly like an AWS configuration file for the CLI. So I'm going to add the magic line to enable client-side monitoring here as well. Oops. Okay, now I'm fine. But as I mentioned, this is not going to take effect because I have to restart the process. So let me do that quickly. Okay, so now the logs should also appear, like all the API calls from the log should appear here. So, but what if things look a little bit different? So let me look into another process. So this time we'll look into, we have probably some SSM agent running. Let me check that. Here, the SSM agent. So that's enabled by default by AWS. So that's why I use that as an example. It runs on all the machines. And here the situation is different. We only have a single environment variable set, the path, but there's no home in here. So here there will be no the SDK will not fetch the configuration file, even that this process runs as the root user. But because the home environment variable is missing, it will not look into the config file. So what can we do here? So one thing to notice or to know is that this process is actually started by systemd. And in systemd, we can edit unit files, and I'm going to do this. And in the unit file, we can add environment variables that are present in the service when started. So this is the other option of enabling client-side monitoring. You configure you add the environment variable AWS _CSM _enabled, and you set that to true, and then it will work. But again, this only has effect as you reload the service. Okay, because we changed the unit file, we have to reload this here before. So, but now SSM agent is restarted, and I lost my session. Very likely. No, it still works. Okay, great. Because this is also this service, the session manager is also part of SSM, but it still seems to work. So that's nice. Okay. So what I did now is I enabled client-side monitoring with the shared configuration file. I enabled it using environment variable, and I also enabled explicitly in a configuration file that was explicitly defined. So those are basically the three options that we have. And now lots of data will be already sent to the UDP port on my machine. So we need something to listen on that port and to forward it into an S3 bucket. And this is where a small tool open source project called FluentD comes into play. So FluentD is kind of a Swiss knife. It does a lot of things, and it can listen on UDP ports, does some transformation, and can then pipe it into an S3 bucket. So that's exactly what we need. So that's why I'm going to install FluentD. And there's a easy way of doing that, optimized for Amazon Linux, provided by the FluentD project. So I'm using exactly this, like the plain installation, nothing secret or hacky that needs to be done. It will just install everything that's needed, and then FluentD works. So that's pretty convenient. I mentioned that we have to upload something to S3, and this means we need permissions to do that. So let me switch to the IAM service, because we need to add some permissions to this machine. Okay, let me look into this. So this is called the IAM role of the machine is the proxy role. So what I'm going to do is I will add an inline policy, and I'm going to use the JSON approach. Okay, so that's the policy that we need. We need to get and upload objects. Get is just because FluentD, for some reasons, looks if the file exists before it uploads it. So that's why we need a get object. Permission because of a head request that is made. And I created an S3 bucket. So let me show you that quickly. So in your case, you probably want to create a bucket first, but I already have a bucket created. So that's my bucket. So that name is taken. You have to come up with something else. And I replace the bucket name here. And now the instance will have permissions to talk to the bucket and upload files there. Okay. So great, that's done. So we have FluentD installed. We have the permissions in place. So now we need to configure FluentD. And this is also something that, again, is prepared. So I will open the configuration file, and we can just wipe out everything that is by default there. We don't need that. And I will, again, paste some magic lines here. Just one information, there will be a blog post published tomorrow with all the code, all the links and stuff like this. So no need to kind of try to write everything down here. Let me go to the top of this file. Okay, so what is actually configured? We define a source in FluentD, and that's an UDP source, and it listens on port 31,000, and it binds to the local interface. So that's not a security kind of issue. The data is only available on the machine. It's not published to the outside world. Then I do a filter. With a filter, we can enrich data, and I add the host name because otherwise we don't know. Like if you have multiple machines, we cannot differentiate them. And the host name includes the instance ID and the IP address. So that's kind of useful. There's also a plugin that adds all the EC2 metadata information to your data. If that's needed, that's also possible. But like to make things a little bit easier, I just use the host name here. And then last but not least, we use the S3 plugin. And here I have to fill in some values. So we have to configure the region and also again the bucket name. Oops, no, that was not a good idea. Okay. So the name of the bucket, let me quickly copy that. Just make sure that I don't make any typos. Okay. So that's all we need to configure. The rest is just some like details. Basically, we flush every 10 minutes or if 256 megabytes are reached, and we will flush with a 1 minute delay. This basically allows late data to arrive into the system. But that's just the general configuration. Okay, so that's it. Now the configuration is done, and we can start the service, the Fluentd service. And that's again done using systemd, and now everything is working. And now basically what you have to do is you have to take a break. And I recommend that you wait maybe 7 days. So everything in the application should be invoked to ensure that all the code paths are went through. I also encourage you to do deployments in the meantime, because we often see things with code deploying going on. So only if a deployment really happens, we will see those API calls. Basically, use whatever tools you use on this machine to ensure that all the API calls are made. So to not waste any time here, I prepared something. So I have an instance running since a few days where data is already fetched. So let's quickly look into the S3 bucket. So all the data is placed underneath the AWS client-side monitoring folder. And then we have we partition the data to make it easier to analyze later with Athena. So that's why we have the year, the month, and also the day. So let's look into today's folder. And then you see a bunch of files created by Fluentd. So that's fine. So how can we actually analyze this data? And the answer is use Athena. But before we can use Athena, we have to create the schema. And there is a service that helps us with that. And this service is called Clue. So let me open that here. And Clue provides us so-called crawlers. And crawlers look into an S3 bucket and analyze the data and create a schema for it. So before I do that, I create a new database. So let me just call this, that's the live database. So database is just like a collection of tables. And now I create a crawler. So we have to give it a name. Let's call it live. It will look into data stores, so that's the correct setting here. And by default, it wants to look into an S3 bucket. That's also fine. So here we can specify the bucket. And my bucket is called client-side monitoring US East 1, and also select the first layer, like the first folder, to make sure that this is going to work well. Then I click on next. I don't want to add another data source. Create an IAM role for me, please do that. And then we want to run this every hour. So that's basically important because when new partitions are added, and this happens basically daily, the Clue crawler will detect that and configure everything correctly. So the database is going to be the live database. And finally, we made it. So that's all the clicks that we have to do. So now this thing runs every hour, and it will next run. I passed like it's one, I just passed it because of 1 minute. And so we will run this manually here. We can just run the crawler, and then it is kicked off, and it looks into the bucket, it looks into the files, and it will figure out the schema. And this only works if there are a couple of files in the bucket. So you have to wait a little bit until data is available. And we are not going to watch how this works because I already did that in preparation as well. So we can dive right into Athena. So that's the service that we're going to use for analyzing the data. So here you see all the databases. So this is the live database. That's the one that I created recently, and my demo database is called AWS Client-Side Monitoring. And now we can run queries against the table. And let me start with the first query. That is a very simple one. It just gets the first 25 items of the table. So now I have to rearrange things here a little bit. And this is just to give us an idea how data looks like. So you see there are two different types of data lines here of rows. One is called API call attempt, the other is called API call. We have the service, we know the API, we get a timestamp and the region. We also get the user agent. The user agent is super important to understand you from where the request comes from. For example, AWS CLI, okay, that's pretty obvious. It's because of an AWS CLI invocation. But we also see something like AWS SDK Ruby. Okay, so that's not the CLI. This is some Ruby code that use the AWS SDK. So this gives you some like hint from where the request actually comes from. So that's why I usually like the user agent. You also see the host name, as I mentioned, and I think that's the most important stuff here. Let me go through that list. Okay, so the rest is not super interesting. But what's the difference between a call attempt and a call? So one call can be retried if there are errors. So if the SDK detects, for example, a 500 return from the API or timeout, it will just retry the same request without forwarding this error to the one who issued the CLI command. And that's then called a call. So a call can have multiple attempts. So what we can do now is we only limit or filter for the real calls. I'm not interested in the attempts because for the analysis that I want to do, I don't care if there was 2 retries or not. I just want to see, okay, what service actions were called. And now I only get the data that I was looking for. Okay, still, I mean, that's not super useful. We should do some aggregation. And the cool thing here is that if you're familiar with SQL, you can just do some group by stuff. So I'm going to group by region, service, and the API. And I will count on that and I order it a little bit. But basically what I get, oops. What's going on here? Invalid request exception. Okay. Sometimes you can just change nothing and it works, but this is really a surprise. Okay, I don't know what was actually the problem, but there was nothing changed. It's working now. So what you see now is aggregated. Like this is only looking at data from today. What API calls were most popular? For example, we do a lot of put log events for CloudWatch logs. We do a lot of put metric data for the CloudWatch service. We do a lot of receive messages and so on and so forth. So there are quite a few interesting things here. So not sure if it's already surprises, but it's still interesting. So, and what I'm going to do now is to show you the difference to what you get out of CloudTrail. So CloudTrail data is can be analyzed in different ways. I will use CloudWatch Insights to do it. You can also use Athena to do the same thing. I'll look into the S3 bucket, but I think it's a little bit more interesting if you use different ways of doing it. So I'm going to use CloudWatch Insights, and my CloudTrail logs are shipped into log stream. So let me select this log stream, and I only want to look at the data from today. Now I have to quickly resize this because the UI is a little bit broken here. Okay, and I run a very similar query. So let me increase the font size again. So I again group by event source and event name. So event source is the service name, event name is the API name, and I count, and then I sort by count. So that's basically kind of the same approach. And then let me run the query. So we expect now to get very similar results. At least that's what I expected when I did this the first time. But there's actually a very big surprise. As you can see, only 3 different API calls were recorded, like the update instance information API call, list users, and complete lifecycle actions. So let's compare that with what we have from Athena. Okay, so update instance information. Okay, we have 215 here. We had a little bit more in S3. That could be because of not all the data is reported yet and not yet flushed. So Let me rerun the query. Maybe it's already there. But if they're like slightly different numbers, so that's totally possible because we are not like that. Both systems are not in sync. So if we run the same query tomorrow, and still looking at the day like yesterday's day, then I expect the numbers to be exactly the same. Okay, so we have update instance information here as well. Then we have list users, 119 calls. I have 107 recorded here. And last but not least, complete lifecycle action 1. And I don't even, oh, okay, I can see that here as well. Okay, that's the same. But as you can see, I don't see put log events in CloudTrail. I don't see put metric data in CloudTrail, receive messages, get messages, head object, put object, and so on and so forth. So this is a big problem because the statement that all the API calls are recorded in CloudTrail is not true. So everything that's called a data event, for example, will not be available in CloudTrail. There are some services where you can explicitly enable it like S3 and DynamoDB, but not, for example, for SQS. So there's no way to use CloudTrail to get this information. So this is where the client-side monitoring really shines. So it provides you more information. But I recommend to combine the two data sources because then it gets very powerful. You can kind of cross-check the data that you have to ensure that you actually have like more, you can be more certain that actually what you measured is correct. So that's why I usually compare the two data sources. And one thing that is completely missing in client-side monitoring is you only see the service and the action. You have no idea about the resource that was invoked. So you cannot really go that deep and check also the resource level constraints of policies. That's not possible. You can get this data in CloudTrail. So that's the benefit of CloudTrail here, but only for the like API calls that are recorded. Okay, so that's it. That was my demo of using client-side monitoring. Now, oh yeah, it's time for questions. So if there are any questions, then feel free to send them into the chat, and I try to answer them as good as possible. Besides that, remember that we will publish a blog post tomorrow, and this blog post will cover exactly the same topic, but you will get all the code and commands and queries that I used here to like easily rerun this approach in your own AWS account. Okay, so I think that's it. If you have any questions or feedback, then we really appreciate if you let us know, send us an email or send us a comment here on YouTube. And that's it. Thanks very much and see you next time. Bye.